Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope you all are doing really great. So students, in this video we are going to see the derivation of force between two parallel current carrying wires, or we can tell conductors also. After that we will see standard definition of 1 ampere current also, very important. We will solve questions, and after that we will also see force between two moving charges. Okay, so let's start the video with the topic. So here you can see I have taken here the two wires. First wire carrying current I1, second wire carrying current I2. They are separated by the distance d. Okay, so let's see now. Let us consider two long straight wires 1 and 2 kept parallel to each other d distance apart and carrying current I1 and I2 respectively as shown in figure. Is it? Now let's see. Magnetic field on wire 2 due to current in wire 1 is given by. Normally what will happen that here, remember that wire 2 is placed in the magnetic field of wire 1 and wire 1 is placed in the magnetic field of wire 2. So only they will interact each other and they will exert force on each other, magnetic force, and that force will be anyhow non-contact force. Is it? So see here now. What I am going to do, first I am going to calculate the force on the wire 2, is it? So for that all the processes I will do. So magnetic field on wire 2 due to infinite wire carrying current I1 is given by, put all your fingers along the current, these fingers along the current, palm towards the observation point, then this thumb will indicate the direction of the magnetic field here, is it? So this one I will write here B21, that means force magnetic field on wire 2 due to wire 1. Okay. After that you know one formula very well. What is the formula? Formula is the force acting on a current carrying element F equal to IL cross B. Is it? To calculate the force I will use this formula. Okay. So now I will take here very small element. Now let's take here length is dl. This length how much here? This length is dl. Okay. So the current element direction is also in this direction, I2 dl. And to get the direction of the force, what I will use here? I will use a right hand thumb rule. I will curl my fingers from first vector to the second vector. That means from the current element IL to vector B. So I2 dl upward, magnetic field inside to IL to B. So thumb is going which side? This side. That means on this length, what will happen? Force will exert in this direction. Okay. And this I will tell here F21, force on 2 due to the current in 1. Is it? Similarly, if I take here the reverse, if I take here the reverse, let's take if I see on this wire, is it? So now I am going to see magnetic field on wire 1 due to wire 2, is it? So put all your fingers along the current, palm towards the observation point, then thumb is going outward, is it? That means magnetic field is outward here. And what we can write here? B12, magnetic field on wire 1 due to current in wire 2, is it? Now after that again I will take here the element dl length. So current element anyhow in this direction, I1 dl. And how to get the direction of the force? The direction of the force means C. I2 dl upward, magnetic field your side. That means C. The curl your fingers from I to B. Now the thumb is going in this direction. That means here I will write here this force will be called here F12, is it? So you can see very well both the forces are acting towards each other. From there we are understanding when the current is flowing in same direction, both the wires will attract each other. And later we will see if the current will flow in opposite direction, the wires will repel each other. Okay. So now first I am going to see this situation. I am going to calculate this force. Okay. So let's see now. As I told you very well, magnetic field on wire 2 due to current I1 in wire 1 is given by this B21. So what is the B21 formula? See here, B21 is given by mu naught and current is I1, and what is the length? You can see this distance is d, wire 2 at a distance of d from wire 1. So mu naught I1 by 2 pi d, is it? This is the magnetic field here. Okay. Now after that what is given? See, magnetic force experienced by dl length of wire 2 due to magnetic field B21 of wire 1 is given by here. Okay, that means I am going to calculate this F21. Can you tell me what is the angle between current element and the magnetic field? You can see very well current element along y direction and the magnetic field is along negative z direction inside the board. So they are making how much angle? 90 degree, is it? And if I write here the magnitude, see the magnitude. if I write here the magnitude, so this used to be how much here? ILB sine theta, okay, and here in this situation theta is 90 degree. So this thing I am going to do here, okay. So just can you see here, okay. So now we are going to see this force F21 now. So if I write here this F21 here, see here, this F21 what can I write here? Current in wire 2, I2, length dl, and magnetic field B21, and anyhow sine 90 degree is it? Now we'll write here, see, I2 into dl, and what is the B21 value? See, mu naught I1 by 2 pi d, is it? So from here I can write here this force how much here? Mu naught I1 I2 by 2 pi d into this length dl. This length dl is there, is it? So we have got here the force. After that, let's see here, very important term, see, force acting per unit length of wire 2. Here we have got the force on dl length, but we want force acting on per unit length. So I can write here, see, F21 is given by here F21 by dl, is it? So what this will come here? Very important formula. Can you see here? Mu naught I1 I2 by 2 pi d. I have written from here. Now dl will come this left side here in a denominator here, is it? So this is the thing is there, very important formula. Remember that here, this formula, very important, okay. See here. After that, if I just do here now, on wire 2 I have done. If similarly I will write here on wire 1, I will write here B12 and F12 directly. Can you see here? So B12 what will be there? That means magnetic field on wire 1 due to wire 2. I can write here mu naught I2 by 2 pi d, and when you will calculate this F12, so it will become here F12 by dl, and what will be the formula? When you will simplify this, again it will come same, mu naught I1 I2 by 2 pi d. Just think somewhat, okay. Now after that, see, hence F21 and F12 follows Newton's third law of motion. Anyhow, they are following Newton's third law of motion. We can see very well here, no? Both the forces are there, they are attracting each other, and you know very well, according to Newton's third law of motion, what is there? Action reaction forces act on two different bodies in opposite direction, okay. So in vector form, what can I write here? I can write the formula like this here. Can you see? F21 is equal to minus of F12, direction opposite. If we write here in a per unit length form, so F21 is equal to minus of F12, okay. And if I write just magnitude on dl length of each one, so magnitude wise F21 is equal to F12. You can see here I have did not put the vector sign is there, is it? So this thing we have covered here. See this thing, this is the force on dl length or any specific length, this is the force on per unit length, and this is the magnitude is there, okay. See here, very important derivation, okay. Next one, let's see here, standard definition of 1 ampere. What is this? Kindly see, if 1 ampere current is passed through each of two parallel wires separated by 1 meter length, then force per unit length on each wire is how much here? 2 into 10 to the power minus 7 Newton per meter, is it? Mathematically, what I want to tell you? I want to tell you like I1 equal to I2 is how much here? 1 ampere. After that, this distance between the wire, how much is given here? 1 meter. And these wires are placed in a air or vacuum. Okay, so when they are vacuum or air, mu naught by 4 pi value will be how much here? 10 to the power minus 7 SI unit. Okay, so in this situation, if I calculate here the force, what will be the force? So kindly see here, magnitude wise both are same. Now, so F12 is F21. What is the formula? See, mu naught I1 I2 by 2 pi d, is it? So what is the value of the mu naught by 2 pi? Now see this mu naught, okay, mu naught value I will put here, see, 4 pi into 10 to the power minus 7, current 1 into 1, and here this is 2 pi and this one is also 1. So 4 pi by 2 pi, what is coming here? Anyhow 2, and see this one here, 10 to the power minus 7 Newton per meter, as we have written here, force per unit length. So remember the unit, this one Newton per meter, is it? Great. After that, let's see here under the important points. First point, what is given here? As I told you, two wires attract each other if currents are flowing in same direction, is it? See, I have done here, see, the current was flowing in same direction, both upward, wires are attracting, is it? Next one, let's see here, two wires ripple each other if currents are flowing in which direction? Can you see? The currents are flowing in a opposite direction. Okay, very very important, very important. After that, next one we will see here some equilibrium cases and all that. Okay, let's see now. Let's see. Now let's see. So equilibrium of free wire here. Okay, so see now. Let a finite wire of length L and mass M is placed at a distance D from the infinite wire. See here, this is the infinite wire, just one support is there from the ground. Okay, and this is the finite wire, blue color. Okay, now see, if current in wires is flowing in such a way that magnetic force on finite wire is equal and opposite to its weight, then finite wire will be in a equilibrium as shown in figure. Okay, so you know very well here now this length of the wire, how much here? L. Length of this wire is L only, and the weight of the wire in which direction? Weight of the wire will be downward direction. So if I want to balance this wire, what should be there? The magnetic force should be in which direction? Magnetic force should be in upward direction. Magnetic force should be in which direction? Upward direction. So in this situation, what should be there? The wire should repel. Repulsion means current in a which direction? Opposite direction. That means in a finite wire, the current will flow in this direction. This one right side, this one left side, then only repulsion will be there and magnetic force upward. Is it? And as I have told you very well, the length of the wire, how much here? The length of the wire, this length of the wire is L. Okay. So can you see here mathematically? What can I write here? Mathematically, this will happen that see, this Fm should be equal to mg. Okay, magnetic force should be balanced by the weight, or we can tell weight should be balanced by the magnetic force, then only equilibrium is there. Is it? Now what is the magnetic force? I can write here, kindly see here, mu naught I1 I2 by how much here? 2 pi, and let's take distance between these wires is d here. Is it? So mu naught I1 I2 by 2 pi d, this is the force per unit length into length here. Okay, and m into g. Okay, so from here just basic thing is as it is. So if I write here, see, if I write, see, mu naught I1 I2 by 2 pi d is equal to m by L into g. Sometimes they will not give the mass of the wire and all that, they will give the linear mass density. M by L is the linear mass density lambda. Is it? So this thing, kindly remember that here the main equilibrium concept is that the magnetic force should balance the weight of the wire. Is it? Based upon that only the current direction will adjust by using the concept. Same current, wire will attract, opposite direction, wire will repel. Is it? Can you see it? Okay, great. Now let's see, the one question is there, very basic question. The question is, see, two very long straight parallel conductors A and B carry current of 5 ampere, 10 ampere respectively and are at a distance of 10 centimeter, okay, from each other. The direction of current in two conductors is same. Direction is same. Direction of same means what will happen? Anyhow, attraction will happen. Attraction is here, attraction is here. So either option B or D is the correct answer. Now see, the force acting per unit length between two conductors is how much here? Is it? So can you see here? Anyhow, the force acting is small f, per unit length na small f. Maybe F12, maybe F21. What is the formula? Can you see here? Mu naught I1 I2 by 2 pi d. Is it? Now after that I can write here what is the value of the mu naught. We can write here, can you see, 4 pi into 10 to the power minus 7. I1 I2. I1 I2 what is given? See, 5 into 10, that means 50. Okay, and this will come here, see, 2 pi into distance between the wires, how much? 10 centimeters. So convert into meter, 10 into 10 to the power minus 2 meter. That means it will become here 10 to the power minus 1. Okay, so after that what will happen that here? We will simplify this here. So see, this will come here twice, and this will come here 2 into 50 100, 10 power minus 7, 10 power minus 1, it will become here 10 power minus 6. So it will come here 10 to the power minus 4 unit per unit length. So Newton per meter. Is it? So which option is correct here, students? You can see very well this one. 1 into 10 power minus 4 Newton per meter, and is attractive. Again, why attractive? Because current in which direction? Same direction. If current opposite direction, then answer will become option A. Remember that direction also very very important. Okay, great. Now let's see, the next question is what? See, the question is, two long straight wires P and Q carrying equal currents 10 ampere each were kept parallel to each other at a 5 centimeter distance. Now, magnitude of magnetic force experienced by 10 centimeter length of wire is how much here? F1. Is it? Now, see, if distance between wires is halved and currents on them are doubled, force F2 on 10 centimeter length of wire, P will be how much here? Okay, so here also force between the wires concept. So first I will write here one by one what they are telling that here. P and Q, they are carrying the equal current here. Okay, so let's take what is given here. IP and IQ both are what? Both are same. Okay, both are same. I have taken here I. Now, distance between the wires is halved. Okay, so what is happening that here? Let's take for example, new distance is, let's take D dash. So D dash is what is coming here? D by 2. Distance is halved and currents on them are doubled. Equal current was there, but what is happening that here? These currents are doubled. Equal only in both of them, current is doubled. So IP dash, IQ dash is equal to 2I. Is it? So what they are asking, what will be the new force? Okay. So you know very well what is the force formula, students. Force formula I can write here, see, F and length and all, they are not changing that much and all. Na? So F you know very well, kindly see here, mu naught I1 I2 by 2 pi d into what we can write here, length. Let's take here dl length is there, na? Dl length is there. Okay. Now after that here, what are the currents are there? Let's take here, this is the current I am telling you P. And what is this is a current Q, IP, IQ, and force how much they are telling? The force they are telling F1. Okay, so you can see here, if I write here, kindly see here, this force F1 is there, is it? This is the F1. After that, if I write here the new force F2, what is the new force F2? Kindly see here, mu naught IP dash IQ dash by 2 pi dash, and length is what? Same only, dl length only. Okay. Now after that, what will happen that here, the students say, I will just divide them. So when I will divide these equations, you know what will happen that here, if I can write here F2 by F1 is equal to mu naught by 2 pi, all will cancel out here. Okay, so this will become here, kindly see here, IP dash IQ dash by IP into IQ, directly proportional now, into distances reciprocal, that means it will become reverse. That means remember that here, this will become here D by D dash. Okay, so I can write here, kindly see here, this F2 by F1 is equal to IP dash IQ dash how much here? 2I, and this is how much here? I. So it will become 2I whole square by I square. So here it will come here 4, and similarly D by D dash will come what here? If you see from here, it will become 2. Okay, so just kindly see very well, it will become 2. So from here I can write here this F2 will be 8 F1. Just think, then answer will come. Very easy. The correct answer is what here? The correct answer is here, option A is the answer, and this is 8 F1. Is it? Great. Now let's see, move to the next one. The question is here. The question is here. 3 straight parallel current carrying conductors are shown in figure. The force experienced by middle conductor of length 25 centimeter is how much here? Okay, this middle conductor is there, its length how much is given here? Let's take the length they are telling here 25 centimeter here. Okay, and this wires, let's take these wires are the infinite wires. Okay, so we will see what we have to calculate the force. So now let's see here, let's take, this is the conductor P. Okay, this is the conductor Q, this is the conductor R. Okay, so now first you think I will calculate force on the conductor Q one by one. Okay, so see here now, this current and this current both in which direction? Kindly see here, the both these currents are in which direction? Opposite direction. Is it? This is upward, this is downward. That means repulsion will happen. Here I can write here force on Q due to P. Okay, after that what will happen that here? Again you see this current upward, this current downward, again repulsion. That means here again one force will be there. This I will write here what? Force on Q due to R. Okay, force on Q due to R. So this is force on Q due to P, and this is force on Q due to R. Both in which direction? Opposite direction. That means to calculate the net force, we have to just subtract the forces. Okay, so let's see one by one. If I calculate here the force FQP, what this will become here? Kindly see here, mu naught, and it will become here current IP, IQ by distance between them 2 pi d and into length here. Okay, remember that here, length. So again I'm telling you, see, mu naught by 2 pi value directly I'm writing because mu naught is 4 pi into 10 power minus 7. So 2 pi will divide, so it will come here 2 into 10 to the power minus 7. Okay. After that, IP, IQ. So here please, this is IP, this is IQ. How much current is there? This is 30 ampere, this is 10 ampere. So 30 into 10, it will come here 300. So 3 into 10 to the power 2, is it? And anyhow the D value what is given here, kindly see 3 centimeter. So 3 into 10 to the power, what is coming here, centimeter, minus 2, is it? So just kindly see very well, no? We have just put the values and all that here, is it? So anyhow what will happen here, kindly see, this 3 and 3 cancel. So this will come here, what here, 2 into 10 to the power how much, minus 2 will go up, plus 4, and here minus 7, minus 2 up na, plus 4 minus 7. So it will come here 10 to the power minus 3 Newton. And length, one more is there here, okay, wait, length is missed here, length we have missed, okay. So see, this length is there, this length we are missing. Length how much is given, kindly see, 25 centimeter. So see, 25 into 10 to the power minus 2, okay. So see, 25 into 10 to the power minus 2. Now let's check out, 25 into 2, 500 into 10 to the power, how much coming, minus 3, minus 2, minus 5, is it? Is it? Because 3 cancel, 10 power minus 4 plus 4 will be there, so minus 3. So 25 into 2, 25 into 2, 50, okay, kindly see here, this is the 50, okay, this is the 50. Now, so what this will happen here, it will happen here, kindly see, 5 into 10 to the power minus 4 Newton, is it? Kindly see here, this is the force FQP. Now after that, if we talk about here FQR here, okay, so see, FQR, what will come here? Again, kindly see here, I will write here mu naught by 2 pi, and here QR means IQ into IR, and let's take distance between them is D dash is there, okay. Now after that, let's put the values, students, here, okay. So mu naught by 2 pi, how much here? Kindly see, 2 into 10 power minus 7 IQ IR. So IQ IR, what will happen? 20 into 10, that means 200. So 2 into 10 to the power 2, and distance between the wires how much here? 5 centimeters. So 5 into 10 to the power minus 2, and length of the wire 25 into 10 to the power minus 2, is it? Now we will simplify this. Here, okay. So what this will happen that here, kindly see here, students, na? So see, 2 into 2, 4, 2 into 2, 4, 25 into 4, 100 by 5, that means 100 by 5, how much here? 20, 100 by 5, 20, this thing I have taken, 2, 25 and 5 here, is it? 20. Powers, let's adjust here, this 10 power 2, this 10 power minus 2 is over, so 10 power minus 7 here, minus 2 will go up, so it will become here 10 to the power minus 5, okay, Newton. So this is coming here, kindly see, 2 into 10 to the power minus 4 Newton. We have got these values, okay, and the forces both are in which direction? Opposite direction. That means, students, if I calculate here the net force, what will happen? We have to do the subtraction. So FQP minus FQR. So here you can see, this is 5 into 10 power minus 4, 2 into 10 power minus 4. So we can write here, kindly see, 5 minus 2 into 10 to the power minus 4 Newton. So 5 minus 2, what is coming here? 3 into 10 power minus 4 Newton. And anyhow, force in which direction? Towards the right side, because this force is more, Is it? Kindly see here. So have to be very careful. Small f means force per unit length. Capital F means we have to see the length also, that we have forget in the starting, is it? Otherwise mistake should have happened. Next one, let's see. This question is here based upon the equilibrium. See, a long horizontal wire is rigidly fixed and carries a 100 ampere current. Another wire of linear mass density 2 into 10 minus 3 kg per meter placed below and parallel to the fixed wire. If the free wire kept 2 centimeter below and hangs in air, then current in free wire is how much here? Okay, so kindly see very well, they are not telling anything, so I have taken current in a fixed wire, how much? They are telling here 100 ampere here. Okay, now distance between the wires how much is given here? 2 centimeter. This here, this D is the 2 centimeter. Okay, and you know very well here, na, this wire wants to go downward here, is it? So magnetic force should be in which direction? Upward direction, is it? So for upward direction means what should happen? The wires should attract each other, is it? So for that, the current will flow I2 in this direction, then only wires will attract. Okay, this is the basic thing. After that, you know very well, for the equilibrium of the wire, what will happen that here? Kindly see, Fm is equal to mg should happen, And what is Fm? Kindly see here, mu naught, I can write here, see, I1 I2 by 2 pi d into length of the wire is equal to mg, is it? Now after that what will happen that here, see, I will write here, see, mu naught by 2 pi together here, okay, and this is I1 I2 by d, and see, length will go this side, m by l, and what is m by l? Lambda into g, okay. So after that, students, if I write here the value of I2, okay, so value of the I2 we can calculate, but okay, it's better to put the values now here, okay. So let's see here, what is the mu naught by 2 pi value? You know very well, 2 into 10 to the power minus 7, is it? After that, I1 I2, so 100 and I2, so 10 to the power 2 I2, is it? And d value how much is given here? 2 centimeters, so 2 into 10 to the power minus 2 is equal to, okay. And what is here? Lambda g. Lambda value how much here? Kindly see, 2 into 10 to the power minus 3. 2 into 10 to the power minus 3 into g, okay. Now after that here we'll cancel the things and all. So kindly see here, this 2 and this 2 anyhow cancelled, okay. And if I write here further, minus 2 will go up, so it will become 10 power plus 4 and minus 7. So 10 to the power minus 3 I2 is equal to 2 into 10 power minus 3g. 10 power minus 3, 10 power minus 3 cancelled, okay. So hence we can write here, this I2 value is what is coming here? 2g here. That means 2, 9.8, so it will come here 19.6 ampere. The current should flow how much here? 19.6 ampere. Correct option is here, option A is the answer, is it? See, very well. Now students, let's see, this thing we have covered. Now we have to see magnetic field due to moving charge, just like according to Biot-Savart's law, okay. So what is happening that here, let's take here one charge q is there having velocity in this direction, you can see, and here at this point, let's take P, I want to calculate the magnetic field due to moving charge. One formula you know very well due to the Biot-Savart law, you know very well, dB equal to, what is this? Mu naught by 4 pi I dl cross r cap by r square. This was the formula due to current carrying wire, okay. Very similar to this formula, what will be there? The formula will be due to moving charge also, okay. So due to this moving charge, I can write here this magnetic field B. You can write dB also, not a problem, okay. Let's take here, I have written dB, not a problem. So what this will happen that here, kindly see here, see, mu naught by 4 pi into, instead of I will write here Q, okay, and it will happen that here vector V cross r cap by r square here, okay. So this is the formula. If you want to write another form also, this will be like this, see, mu naught by 4 pi into Q vector V cross vector r, because r cap is vector r by r, so it will become here rq, is it? So any formula you can write here, no, not a problem here, no. And the direction means you have to curl your fingers from vector V to r. So curl your fingers from V to r, that means the magnetic field in this direction is there, okay. See, V to r, right hand thumb rule, is it? If I talk about the magnitude, okay, so see here students, if I talk about here the magnitude, this magnitude dB will be how much here? Kindly see here, mu naught by 4 pi, and I can write here C and mod V cap cross r cap by r square here, okay. So from here, see here, mu naught by 4 pi Q V cross r, that means VB sin theta, no? V cross r means VR sin theta, magnitude of V is V anyhow, magnitude of r cap unit vector is 1, so mu naught by 4 pi QV sin theta by r square here, okay. So what is this here? This is the magnitude, okay. So these two formulas very important. This is one formula, magnitude here, okay, and this is anyhow I have told you the formula in a vector form, okay. Can you see? Very well, is it? So if I talk about here the cases, so first case, remember that here, for example, if I take here theta equal to 0 degree, that means what is happening that here? This is the charge particle Q, it is moving in this direction with velocity V, okay, and the magnetic field I want to calculate along the direction. Let's take here, I have taken some point P, so you can see very well here, velocity and r both in which direction? Same direction. So in this situation, theta 0, even if you calculate, let's take you want to calculate the magnetic field here, P dash here. So here you can see very well here, in that situation what will happen that here, the vector r will be in opposite direction here. So whether you calculate at point P dash or you calculate at point P, in this situation theta how much here? 0 degree, in this situation, if you want to calculate theta, how much here? 180 degree, and either sine 0, sine 180, answer will be how much here? 0. So 0 degree or 180 degree, what will happen that here? This magnetic field dB will be how much here? 0. Remember that here. Okay, and this is the diagram. This is the diagram. Is it? Remember that. Next one, if I talk about here, if theta equal to 90 degree, in this situation, what will happen that here? It will be the maximum. Okay, so see here, please, let's take for example, this is Q moving in this direction with velocity V, but I want to calculate magnetic field here. This is here. Now this is my position vector R. Okay, so how much angle is there? 90 degree. So in this situation, what will happen that here? The formula will come here. Kindly see here. This dB equal to, I can write here, mu naught by 4 pi. Is it? So mu naught by 4 pi into QV sine 90. Sine 90 how much here? 1. So QV by R square here. Is it? QV by R square. Okay. So this is the theta equal to 90 degree situation. Direction of the magnetic field in which direction? Curl your fingers from V to R. So V to R, that means here magnetic field will be inside. V to R we have to curl. Okay. In case of positive charge. Negative charge means direction will become reverse. Okay. Great. Now let's see here, the students. The question is, see here, the question is, an electron in a hydrogen atom revolves around its nucleus with a speed of 6.76 into 10 power 6 meter per second in an orbit of radius 0.52 angstrom. The magnetic field produced at the nucleus of the hydrogen atom is how much here? Okay, so what I am telling you here, let's take for example, here I have taken here electron is revolving here. No? Let's take electron is revolving here, and here I have the nucleus ZE. Z is the atomic number. Okay, so what will happen that here, as I have told you very well, no? Let's take charge is there, no? So charge, let's take at any instant charge is here. The velocity will be this side here, no? Instantaneous velocity. And if we talk about here the position vector, so see my position vector is the nucleus. Okay, so tangent and radius always makes how much angle? 90 degree. Remember that here. Okay, and this is anyhow my, what is this? The radius is there. Okay, so what we can write here, the magnetic field at the nucleus. What is the formula? Kindly see here, mu naught by 4 pi into QV by R square. Okay, R square. You can write capital R square, not a problem, because theta how much here? 90 degree. Okay, after that kindly see here, this will come 2 into mu naught by 4 pi. Mu naught by 4 pi here. No? So mu naught by 4 pi, what this will come here? It will come here 10 to the power minus 7. This will come what here, students? 10 to the power minus 7. Q value, what is given? Electron is given, is it? That means 1.6 into 10 to the power minus 19. Speed, how much is given here? Kindly see, 6.76 into 10 to the power 6. Okay, and after that R square, how much is given? 0.52 angstrom here. So remember that here 0.52 angstrom is into 10 to the power minus 10 meter. Or you can write, see, 52 into 10 to the power minus 12 meter here. Okay, so I can write here what here? Kindly see, 52 into 10 to the power minus 12 square. Just simplify this and all that here, it will come here the 40 Tesla. Is it? Remember that here. No? So very important question came in a JEE 2023 here. Okay, now we are going to see here important topic. We have seen force between two parallel wires. Now we'll see force between two moving point charges here. Basic is all same only. Okay, so see here now. Here I have taken here the two charges. This is charge Q1, this is charge Q2. Velocity V1, this is velocity V2 separated by R distance. Okay, so see here. Let us consider 2 point charges Q1 and Q2 are moving with velocities V1 and V2 respectively, and at any instant distance between them is R as shown in a figure. Okay, now see, similar story. What is given? See, magnetic field on Q2 due to motion of Q1 is given by here. Na? So again in the same way, here I have taken here Q2. So just kindly see here, what is the direction of the magnetic field on Q2? Is it? So you can see very well the velocity is the upward, and this is this side here. Na? This is the position vector, this side is there. So V cross R cap, magnetic field will be inside. Even another way is also there. Put all your fingers along the velocity, palm towards the observation point. Then what will happen that here? This will be the B21 in the same way, B21. After that, what is the force? For the force formula, you know, force acting on the moving charge particle, F equal to Q V cross B. Is it? I hope so you know this formula. Is it? So when you will use this formula, F equal to Q V cross B. So V is upward, magnetic field inside, so V cross B. That means what will happen that here? This is the force, I can write here F21. Is it? If I do the reverse situation, let's take reverse situation. If I calculate B12, that means magnetic field on Q1 due to motion of charge Q2. So here please, my velocity is along the, my fingers are along the velocity, palm towards the observation point, thumb is coming outside. Is it? That means here what will happen that here the magnetic field will be outside B12. Is it? And again use this formula, V cross B. V is upward, magnetic field outside. So V cross B, this is going this side here. So this will come here, the what here? F12. Again here Newton's third law of motion is there. Is it? So see, magnetic field on Q2 due to motion of Q1 is given here. That means B21. What is B21 is there? Kindly see here, mu naught by 4 pi. Remember, magnitude we are writing QV sin theta by R square. Angle between position vector and the velocity, you can see position vector along the x direction, velocity along y direction. X and y axis making how much angle? 90 degree. Is it? So mu naught by 4 pi into Q1 V1 by R square here. Is it? This is the magnetic field on 2 due to motion of a charged one. Is it? Now after that, let's see here. Magnetic force experienced by Q2 due to magnetic field B21 of Q1 is given here. Okay. So for that we have to write here the magnetic field expression here. So F equal to, remember that here, QVB sin theta. This is the formula. Is it? And sin theta how much here? Force means you see V cross B. V along y axis, magnetic field along z axis, how much angle? 90 degrees. So sin 90 will be there. So I will use this one here. In this situation I will write here Q2 V2 B21. What to write? Q2, charge Q2, velocity V2, magnetic field how much? B21. Angle how much here? 90 degree here. Is it? Kindly see here. Very well. Okay. So now I am going to write here this one here. See, if I write here, this is the F21. So what I told you, see here, Q2 V2, is it? And this will be how much here? B21. Is it? So kindly see here, this is the Q2, this is V2, is it? And what is the B21? As I told you very well, see, mu naught by 4 pi into Q1 V1 by R square here. Is it? So from here, students, if I write here, this will become here, kindly see, mu naught by 4 pi, is it? Into Q1 Q2 V1 V2 by R square here. Very, very important. Mu naught by 4 pi Q1 Q2 V1 V2 by what? R square. Is it? Similarly, in the B12, that means magnetic field on charge 1 due to the motion of charge 2. So what is the formula? You know very well. Mu naught by 4 pi, here I will write here Q2 V2 by R square. Is it? Magnetic field on charge 1 due to motion of 2. And when you will calculate F12, that also it will be what here, students? This will be same only. This F12 value will be same only. See here, in a vacuum, okay, or air. Mu naught by 4 pi, same story. Q1 Q2 V1 V2 by R square. Just have to think. Very important formula. Okay, remember that here. Next one, see, relation between magnetic and electric force between charges. Important. Okay, so see, if I talk about here the magnetic force, what we have got here? Maybe F12, maybe F21. What is the formula here, students? Can you see? Mu naught by 4 pi, and here Q1 Q2 V1 V2 by R square. This is the magnetic force between the moving charges. And from the Coulomb's law, you know very well what is the electrostatic force. If I write here, yes, 1 by 4 pi epsilon naught into Q1 Q2 by R square. If both the charges are like charges, they will repel. Unlike charges, they will attract. I am just writing here the magnitude. Okay. So if I take here the ratio, let's take, I am writing here Fm by Fe. This ratio I am writing Fm by Fe. So what this will happen that here, kindly see, mu naught by 4 pi Q1 Q2 V1 V2 by R square into Fe value how much here? Kindly see here, 1 by 4 pi epsilon naught here. So 4 pi epsilon naught will come here into this will come here Q1 Q2 by how much coming here? R square. Is it? Now students, rest of the things will cancel out here. So see here, this Q1 Q2, this Q1 Q2 cancel, this R square cancel, and this 4 pi also cancel. Okay. That means we can write here, very, very important, very interesting. So see, Fm by Fe is equal to what is coming now here? Mu naught epsilon naught. Is it? See, this mu naught epsilon naught, and here V1 V2. See here, mu naught epsilon naught into V1 V2. And what is mu naught epsilon naught? In our electromagnetic waves chapter we will see mu naught epsilon naught is called 1 by c square. And what is this here? This will be V1 into V2. So V1 into V2 by c square, this will be the formula Fm by Fe. Okay, Fm by Fe, this is the formula V1 by V2, V1 into V2 by c square here. Special case, if both are moving with the same speed, V1 equal to V2 equal to V, hence very important, see, this Fm by Fe will be equal to V into V square, so it will become here V by c square. Remember that they will ask directly in exam, when the two charges are moving, magnetic force and electric field ratio, the electric force ratio will be how much here? V by c square. Can you see? Very well. Is it? So students, I hope so. This video based upon force between two current carrying wires and force between two moving charges is very clear to you. Keep studying, keep working.